Arc. So how do you start an arc? Well, you either have to create a sketch or you have to already be in a sketch. Now, to save a bit of time, I've already created a sketch, so let's just edit that one. Now, once you edit it, if you go to here, you can here with an arc, or what I've done is I've actually created a little shortcut, which is Shift A. And that's how I said to you before, how you create a shortcut for doing something. So if I do Shift A, the default is the 2-point arc. Is it 2-point, 3-point? 3-point arc, sorry. So when you do that one, that's over here, which is the 3-point arc. You click the first point, so it says there, place start point. You place the end point, and then what it asks you to do is place a point on the arc. It does not have to be in the middle. It can be across to the right. It can be across to the left. It can even be downwards. It doesn't really matter where you click. That will create a 3-point arc. Now, what that's specifically designed for, we do that one again, Shift A. Oh, that's it. The other thing to remember is that when you do an arc, once you click that final point, it's already ready to do another arc. You don't have to do the arc command again. So realistically, a 3-point arc is specifically designed to place at a start point, to go across to an end point, and then to lift up to a distance. Now, one thing that's very interesting with this, if we place the start point, we place the end point. If you drag this and keep dragging and dragging and dragging and dragging and dragging, you will eventually get, and that's quite dim on the screen, there is around the 2 circles at the end of those lines. They've now got a blue line around them and a horizontal line above it. When I click that, what it has actually done is created a perfect arc. Now, a perfect arc, if we do a dimension, if I take the dimension from there to there, that one is 100 millimeters. And if I take a dimension of the radius, that radius is 50 millimeters. Now, because we're going to cover dimensions at a later stage, I'm not going to go into why this is a driven or a driving dimension, but let's just for now create it driven. You can then obviously here, we can create a dimension from that point there to that point there, and we can make that, let's say, 120 millimeters. And we can then create a dimension from there, and we can, let's make that, I don't know, 200 millimeters. This is going to go flying all over the place. Now, again, going back to the constraints, let's just put a horizontal constraint on there and there, just to make this simpler. You have now a dimension which is between the 2 points, and you have also a radius dimension, which is this one. So we can then make that, let's say, 50 millimeters, and that radius will still stay at 200 millimeters. So we can then reduce that down to, say, 75 millimeters. We can reduce that down to 40 millimeters. And we can reduce that down to 25 millimeters. What we cannot do is reduce that down to 24 millimeters. It will come up with an error. And that's pretty obvious, because if that dimension is 50, that dimension from there to there must be 25 or greater. Okay. So that's the different ways of dimensioning a 3-point arc. The other one we have, if we do Shift A, is we have a center point arc. Now, a center point arc, very, very simple. What you do is you create the center point, you come across to the start point, and then you can revolve that around to 180 degrees. Now, you might be thinking, well, is that not the same as that one? Well, no, because if you just wanted an arc and you wanted to start it here, it's far easier to place the center point at the end of that construction line, then to go to the end there, that's 50 mil, and then rotate that around, and that makes 180 degrees. But it gets a little bit better than that. What you can do is you can create the center point. You can come out to a dimension that way. And then as you start coming around, what you'll notice is it comes up with degrees. So if I type in 45 degrees, I have now got two construction lines and an arc at 45 degrees. So I can alter that. Let's double click that one and let's make that 55 degrees. So I can alter that angle. That's no problem at all. And what I can also do is dimension one of these lines. So if I wanted to make that 66, that would make an arc that is 66 mil from that point to there, and it revolves or arcs around 55 degrees. Obviously, I can't dimension that one because it's identical to that one, so it just won't let you do it. If I want to now dimension these, if I do a dimension from there to there, and I make that 120 mil, it goes a bit Pete Tong because there's no constraints on it. A quick get around for that one is, instead of using that as a dimension, use that point there because it is a center point arc to that point there, and let's make that 60, and that now stops it from flipping around. You can then put a dimension there, but again we go back to the driven aspect. Because this can only create a perfect arc, in this occasion I can't change the radius, but I can do on this one. So if I do a dimension from there to there, and let's make that one 120, this is going to go a bit, this stays without flipping it this time. But if I put a dimension on there and I come across to here and make that, I don't know, 200, trying to think what this is going to do. It's going to go up there somewhere. So you can do the dimension of the 2 points on a center point arc. And you can change the radius as long as it's not linked to any other geometry. So what we could do then is we can put, again, a horizontal constraint between there, and then that way that will allow us to change that one to, let's say, 60. We could maybe change that one there to 120. Okay, so you can alter the dimensions depending on how your geometry or your sketch, your arcs are currently locked. The final one, if we do Shift A, as we are, oh, good, 2 minutes, should just about manage it. We have the tangent arc. Now, the tangent arc, you can't start in space. It's not possible, because a tangent arc needs to start at a point. So let's start on the end of this line. And then from there, you can take that arc to wherever you want. Go left or right. It really doesn't make any difference. And one thing you'll notice there is a dimension comes up. This gives you an option where if you want a radius of that, let's say 50 mil, I can then, however I bring that arc now, it will be locked as a radius of 50 mil. The other thing also to note, when you come down to here, this is where you get the auto construction lines. These don't stay, but they give you an indication that when you stop there, you are at a horizontal position to where you started. So that's, put that back to 50, that's there. And if I stop there, that gives me a arc that is perfectly tangent with this line, and it currently has a radius of 50 mil. So if I do arc again, tangent arc, I can start from another arc. So I can start from there, come across, I can do 50 mil again. And then that will then continue and I should get my construction line. So I can do that again. I can go from there. And if I make that 50, I can drag that over there. I can finish there. Good thing about that is that that's tangent with that. That is tangent with that. And that is tangent with that. I can then change the dimensions. So I can change that then to 25. I can change that one to 25. And I can change that one to 25. It's not stayed on the horizontal. Well, that's because those construction lines that were there were only a guide. They weren't fixed in. So we would have to do a horizontal constraint between there and there. We have to do another one between there and there, and another one between there and there. Now, if we did a line now, oops, let's come out of there. If we did a line and we come straight down to there, and we come across to there. What that would allow us to do now, because that's really pretty much constrained, if I changed those dimensions now, and I changed them to 10, and I changed that one to 10, which is when it goes horribly wrong, Russ, isn't it? And then I changed that one to 10. You can see that I've still retained that shape. It's kept its integrity and everything there. If I just hide dimensions and hide the constraints, that's all nice and tangent, and I've changed just those dimensions. So this is why sometimes when we go back to why would you potentially want something constrained and why would you not? Because if we didn't have those constraints there, once I start altering these, then oops, once I start altering these dimensions, that shape would not stay the same.